Hi, my name is Darryn La Zar. I'm Vice President of Sales and Marketing for Wineman Technologies. I'm going to be discussing a heat recovery system developed by our customer EcoGen. The EcoGen thermo-efficient heat recovery system uses supercritical CO2 as the working fluid, providing improved efficiencies in capturing wasted heat from manufacturing processes. The system is comprised of three major components: the heat exchanger, located within the existing process, the EcoGen heat recovery skid, and finally a cold end cooling system. The heat engine is comprised of five primary components: heat exchangers, working fluids, pumps, an expansion device, and a generator, which allow it to uniquely produce power from a range of thermal sources. The working fluid, supercritical CO2, is pumped around a closed loop via the primary system pump. A heat exchanger adds thermal energy to the CO2 before the fluid is introduced to the expansion device, which converts the energy in the CO2 into electrical energy by way of the generator. Additional heat exchangers condense the fluid before returning it to the system pump and recycle heat within the system. Unconverted heat is discharged from the system through a water or air-cooled compressor. The control and data acquisition for process monitoring was developed utilizing LabVIEW and CompactRIO. System requirements include acquiring data from more than 75 sensors and controlling more than 40 devices through Modbus, analog, and digital signals. Additionally, we use multiple PIDs to control the system based on various readings, including system pressure, fluid heat, system mass, flow, and turbine load at different locations within the system. Other requirements include monitoring more than 50 digital feedback signals, monitoring, logging, and taking action on 90 process alarms, logging data for more than 150 signals, data archiving, manual control, Modbus communication to a variable frequency drive, mass flow sensor and turbine load control, monitoring from remote locations, and performing real-time computations of more than 25 process parameters. With all of these requirements, National Instruments tools provided the ideal development platform. Flexibility of the thermo-efficient heat recovery system allows it to be deployed across a wide range of applications while providing process cost savings in manufacturing processes. Environmentally, emissions will be reduced by decreasing the amount of fuel used in manufacturing processes by capturing wasted heat. The net result is a reduction in our carbon footprint. And ultimately, a cleaner environment and increased energy availability by reducing the demand from the highest consumers of energy.